Okay. Anyways, the lower half of all the bearings, all 5 bearings is put in. We sanded our thrust here. I showed you that earlier. And now we're gonna I'm gonna lubricate it. It's a neat little can here. So what's in here is it's driven BR30. And the oil is driven BR30 break-in oil. That's what I use. That's what's in this can. For my cylinders, I use Type F transmission fluid. That's in this can. BR30 Type F transmission fluid in this one. So, we give her a little squirt here. And make sure we lube up middle and the sides. And just a little bit there. And then a trick to the crankshaft is, lowering the crankshaft, is I put a bolt in the where your flywheel hooks to hold it better. Because if you put lowering the crankshaft in and you don't have a long bolt in the back of it here, your fingers are going to get pinched in between the block and the crank. So nobody wants any pinched fingers, so I put a bolt in the back of it, about, I don't know what it is, 4-inch bolt, something like that, and I'll lay it in real nice. So you line it up, set it down nice and easy. Just like that. See, I had the bolt there. Right here, my fingers didn't get caught in it. As I put this bolt in the back. There it is. It's an ARP 7/16. I don't know what it is. 4 inches long. I leave it in here because I don't feel like getting my fingers pinched. So now we'll put on our lubricator, our upper half of the bearing, a little bit. Driven BR30 on the side. That's what I use. You don't have to necessarily use what I use, but I talk to a lot of people on oils, let me tell you. That's what I use for braking. Driven BR30. Okay, make sure that the cap's pointing in the right direction. It all has to go to the front of the block. Just like that. This one, just about push on with your hands. So this one, if you ever look, the mains are called splayed caps, something like that, where they go like this. So I got studs in. You gotta pull these studs out every time, or else you can't get the cap off, because the way the bolts go in at an angle, you can't pull the cap straight off. You don't pull these out every time. So. And so I'm going to screw in these mains. The mains get screwed in. This one I have to screw in with a screwdriver because my oil pickup had to be cut down for the oil pickup. The other one gets screwed in with an Allen. And studs, they never get tightened down. I just run them down till they stop. I don't go any further with it. I just run it down. If that stops, done. Check these. Yeah, that one's good. I think I got the Allen in my pocket here. Takes a little different Allen for this one because it's for the oil pickup. That's why it looks it's a little longer than the rest. So That's at the end, maybe back it off just a little bit, good. And then, big bolts go in. Always the ARP facing up. This one's not. ARP facing up. ARP facing up. Anyways, same thing we did before. Snub it up. Start with your big ones first when you're torquing it up. When you're untorquing it, you start with the small ones. Basically the opposite way you're going to do it. Opposite way you're torquing it. Alright, so I'm going to go 20. This one I'm going to go 30. I'm going to go 40. So I'm going to go 50. 60. And when you're uninstalling a main cap, you never untorque one bolt all the way. You always go in quarter turns when you're untorquing it. Quarter turn on this one, go back to this one. Quarter turn off on this one, go back to this one. Quarter turn, quarter turn. Because if you just take off on one bolt, it starts tweaking the block and tweaking your mains. And then you're in trouble. So that's why you gotta take it off just like you torque it. You take it to torque it in steps of 5. You take it off in steps of 5. Anyways, I kind of forgot what it was, but I'll figure it out here. I'll go, looks like 60. I'll go 70. 80. 90. 100. 100. Okay. Outside ones, tighten them up, snub them, make sure you're even. I'm going to go 20. This one will go to 30. This one will go to 40. This one will go to 50. 60. 70. Turn red again. 70. Okay. Take your dowel bore gauge. Spin it a little bit. The bolts in the way. So take our dowel bore gauge. Turn the magnet on. Make sure it's real straight. Straight to the crankshaft. Straight like this. You get a false reading. So, set it at 0. Now I'll just take a screwdriver. Anything really. Doesn't take much. And I'll just give it a little pry somewhere. And I set it 0 again. I'll pry it the other way. I'll pry it this way. Pry it the other way. Looks to me like I got exactly 5. Which is pretty damn good. Just a tick under 5. And I mean just a little under 5. You don't, if you push it a little bit, you can call it 5, but it's such a little bit under 5, I couldn't even tell you how much under 5. It's a half a line under 5. So, I'm gonna call it good. 5 is, we're looking for 6 and got 5. I don't know. It's a good 5 too, because I'm not putting much pressure on it to move it back and forth. And, you know, because you can push it and get more than that out of it, but it's not a true reading. I got 5 there. 5's nice. So I'm buying off on that. Remember, anytime you're building a high performance motor, everything has to be absolutely perfect. It's got to be dead nuts perfect, or else you're going to be in trouble. It's going to bite you every time. The one thing that you say, oh, it's close enough, or it's good enough, or anything like that, I guarantee that it's going to bite you. So everything has to be perfect, everything has to be 100%, everything has to be Loctite. Anyways, I'll get back to you on what we're going to do next. Well, hello again, we're back. So I figured out what we're going to do next is we just checked our thrust. We know we got 5 thousandths. I can move it with my fingers. You can hear that? Probably not, but it moves real nice. So now what we got to check is we torque all the mains down, and then we check our thrust again and see how if the crankshaft spins nice in the block or not, because that's going to tell us the whole deal. My oil clearances for the mains have been checked on this thing. I probably checked them 5-10 times, so I know that my clearances are good. We just did the thrust, we know we got 5 thousandths in there. So now we oiled them. You got to check your studs to make sure they're seated in the block all the way. Anytime you loosen anything up, the studs unscrew. Sometimes they back out, so you got to make sure that all your studs are all bottomed out. I got oil in it. I used the BR30 driven, my gold oil can. Made sure they're all lubricated. Studs are bottomed out. ARP Ultra Torque on all the studs and nuts. And then now I'm going to show you the sequence, and then we're going to see how the crankshaft spins real nice in there, and check our thrust. So this is the sequence. You start with the middle one, like I was telling you about. Oh, the middle one's already torqued down. Okay, so when you do the middle one's already torqued down the spec. So then this one would be next. So it's the middle, 2, 3, your outer ones. We're going to start with number 2. So once again, just snub it up. I'll go to 20 pounds. I'll go to the other side, 30 pounds, and back to the other side, 40, 50, 60. Anyways, I'm not going to bore you with this. I'm sure you guys know how to torque up the block. Big ones first, and the outer ones second, and your little end ones, they're little 3/8 last. Right. Okay. Mains are all torqued up. Inner ones, the big ones, 100 pounds, all 5. The outer ones on the middle 3 is 70 pounds. And the very outers on 1 and 5 is 45 pounds. So he's got 45 on the little ones, 70 pounds on the medium sized studs, 100 pounds on the inner studs, the big ones. And see that? See how nice that is? Real nice. It takes absolutely no, I don't have to really twist the crankshaft to spin it. Absolutely none. Just, I grab it with my hand like this, the nose, like that, spins beautifully. That's what you're looking for. It's got to spin like that. So now we're going to check our thrust again. We got it all torqued up. Got to check our thrust. Got to make sure we still got the 5. If we don't have the 5 in there, I got to take it all apart again and get the 5 in there. So this is part of building a motor. This is why a machine shop or somebody that's assembling a motor, they get it done real quick and maybe things don't work out too good for you because they get $100 an hour, $150 an hour. I don't know what shop time is. I've never really had a shop build my motors for me. I was shown through my father and shown through my friends, so I don't know because I've never had anybody build a motor but myself, and knock on wood, I've never blown one up. I've had some lifter failures, so that's why this car's all taken apart, is because of lifter failures. I'm not going to tell you who the manufacturer was that made them. There's several manufacturers, but once again, pay close attention to the parts that I'm in the list that I give you now, because you know everybody's so happy. And my feeling about the lifters, and this is my personal feeling about lifters, is I think these manufacturers, and I'm not going to say who they are calling up China and saying, you know, they give the China the specifications that they want for the lifters, and they say, can you make me these lifters? And you know, China turns around and says, sure, we can make those lifters for you. How much? And China says, well, $50 for 16 lifters. Oh, they say, good, okay, as long as it's to our specification, perfect, make them. So then the Chinese make these lifters for $50, and the manufacturer, I'm not going to tell you who it is, turns around and sells it to you and me for $1,000. And then you and me put them in a motor, and it only lasts a year. And you paid $1,000 for so lifters, you only get a year out of them. So anyways, I'm not happy about these manufacturers and lifters, but I'm not going to tell you who they are, so I'll get sued. But pay close attention to what I'm running now. All right, thanks. Okay, this is John again. We have our dial indicator set up on the crankshaft. I'm going to make sure it's nice and straight, parallel to the crankshaft, nice and straight. Well, the lifter thing, I have no shred of proof to prove that that's what's happening. It's just my own theory on lifters. Anyways, let's see what we got here. I'm just going to push it back and forth by hand. Set the 0 again. Looks like we got exactly what we had before. Just a squelch under 5. This is a squelch. So that's exactly what we had before to start with. And now the mains are all torqued down. That's what we got now, which is perfect. Remember what I said, the motor has to be perfect. So now we got our oil clearances on the mains. Caps are all torqued down. Our thrust is correct. Now you remember me talking to you about the mains having a standard bearing and an X bearing. Standard bearing being standard, X bearing being 1/1000ths more clearance. Well, guess what? Connecting rods got the same thing. All right. Let's see if I'll go grab my my connecting rod bearings. Okay. Connecting rod bearings. Now remember, I got, let's bring this up a little bit. Maybe better here. There we go. So, just like your crankshaft, you have standard bearings and X bearings. Okay. Not necessarily really standard bearings, but they're high performance standard bearings. I don't know if you can see that or not. Looks like it's upside down. Anyways, I'll read it to you anyways. This is the 302, the crankshaft that I had made has a small block Chevy rod journal diameter. I don't make small block Chevy makes two different ones. They make a 125. They make a 2-inch. This is a 2-inch. This is the small block Chevy small journal diameter, which is the part number for this particular connecting rod that I'm running is CB 745H, stands for high performance. X stands for, you know, an extra 1/1000th oil clearance. N stands for narrowed, so the bearing's narrowed. And the K stands for tri-armor coating. Now, these connecting rod bearings, they had to be modified because I have a pressure-fed wrist pin, and the connecting rods that I bought on eBay were narrower than the normal. I think a normal connecting rod is 831 in the width, and these end up being 800. So the crankshaft had to be specially made to fit my connecting rods. So that's how I got the connecting rods for $400 instead of $2,700. Because the connecting rods were a little weird, but they had a 5/431 center to center, and small block Ford takes a 5/400 rod to make a 347. Is a 3/400 stroke and a 5/400 rod. That's the connecting rod from the big end to the small end is 5 inches 400 thousandths. These connecting rods that I picked up on eBay were actually a Roche and Yates rod out of one of their multiple combinations that they build. They try all kinds of different things. Different rod widths, different rod diameters, different rod lengths, whatever they can try to make more power. So this was kind of a Roche and Yates connecting rod, but the connecting rods were brand new and never used, but they had a real weird size. It had an 866 pin, which now that's the piston pin diameter is 866. And normally you want to run a 927 pin because that's a standard pin that just about everybody uses. And it's a Chevy pin, 927. This so happened to have an 866 pin in it, so the pin was smaller, and the small end of the rod was offset. It was a 5/461 was the center to center on it. So I had my machinist machine it, the small end back down to the big end, which gave me 5/431 center to center, and then we put an oversized bushing in it, 29 to 27 bushing. Anyways, this probably sounds a little complicated to somebody that really didn't know what they're listening to. I shouldn't get into it, make it that complicated for you. But needless to say, the rod bearings had to be machined. If you see, there's a radius on there because they had to be cut down. And then on the side of a connecting rod, you have the two ends of the connecting rod that meet each other. You'll say like on number 1 and number 5, they meet each other. And the two sides that are flat go against each other, and the two sides of the rods that have the radius in it go towards the radius of the crankshaft. I'll show you this and explain it better to you, and so you know what I'm talking about. They're kind of getting a little bit complicated, but I'm gonna show you. Anyways, I'll show you what's happening.